Hello everyone. In this video, we're going to be looking at a functional equation. We have f of x minus f of 1 minus x equals x, and we're going to try to find an f of x that satisfies this condition. This video actually has two parts. First part, we're gonna look for f of x, and the second part, as I promised earlier, I'm going to talk about how you can come up with functional equations, kind of show you how I do it pretty much. All right, let's get started. So we have this functional equation, and we're going to be looking for an f of x that satisfies this condition. So one of the things that I'm thinking about is, can f be a linear function? Why am I thinking that? Because the difference is linear, and they kind of seem to be different. So, you know, that's just an idea, right? Okay, anyways. So what happens if f of x is equal to ax plus b? Then f of 1 minus x is going to be a times 1 minus x plus b. If you expand that a little bit, you're going to get a minus ax plus b. Now I'm supposed to subtract those and set the result equal to x. So if you subtract ax minus ax plus b minus this, and it's supposed to equal x, and hopefully I should be able to find a and b from here. Let's see what happens. Ax plus b minus a plus ax minus b. So the b cancels out. That's good. We end up with a simpler expression. 2ax minus a equals x. Okay, so we kind of have like two polynomials on either side, or two polynomials together. They're equal to each other for every value of x in the domain. So it means the coefficient of x should be the same on both sides, because this doesn't depend on x. They're always equivalent. You can also say that. So this means 2a equals 1, which means a equals 1/2. But on the other hand, we have a constant here, but we don't have a constant here. That means a should equal 0. But these two can't happen at the same time. That is a contradiction. This is impossible. Therefore, this at least tells us that f of x cannot be linear. Now, if you found a solution from here, we could say that, hey, this function satisfies the equation, but we couldn't easily say, hey, this is the only solution, right? So we have to kind of prove that there are no other solutions. Anyways, that's a difficult task, by the way. Let's go ahead and explore this problem in a different way. So, first of all, the biggest question here is, can we find f of x? And the answer is no. Why? Let me explain. Okay, so let me rewrite the equation. F of x minus f of 1 minus x equals x. And by the way, I forgot to say, f is defined from real numbers to real numbers. So that kind of allows you to use any x value you want. You have that freedom. Now, why did I say there are no solutions? Let's go ahead and take a look at it. Suppose, since this equation is satisfied for all real numbers, set x equals 1. What happens if you set x equals 1? You just substitute everywhere. And be careful, because if you substitute x in one place, you have to do it everywhere. So this is going to be f of 1 minus f of 0 equals x, which is 1. Now, notice that I got f of 0 from this equation. So that kind of motivates me to set x equals 0 next, because that's going to give me another expression that has f of 0. Hopefully, I'm going to be able to solve from there. At least f of 1 or f of 0, if I can find it, maybe I can go from there. If you replace x with 0 in the original equation, then you get the following. F of 0 minus f of 1 minus 0, which is 1. F of 1 equals x, which is 0. Now, this might look like a nice system, but it's not nice at all. And especially, you're going to realize that it's not nice at all if you just try to solve it. Let's go ahead and add them up. And my goal is to solve this problem by elimination, because f of 1 minus f of 1 is 0. F of 0 minus f of 0. So everything cancels out. That's the problem. Because now we end up with 0 on the left-hand side, but 1 on the right-hand side. And as you know, and you should know, hopefully you do, that this is impossible. No way! This is impossible. Okay, so 0 does not equal 1. We know that at least, right? So this means that there are no functions that satisfy this. Wait a minute. Is there another way to look at it? Of course. Let's go ahead and take a look at it from another perspective. How about setting x equals 1/2? It's a shorter way to arrive at the result, because notice that when x equals 1/2, x and 1 minus x are equal. So it's kind of cool. They are equal, and this is cool. F of 1/2 minus f of 1 minus 1/2, which is f of 1/2 again, equals x, which is 1/2. Hey, another thing that doesn't make sense. 0 equals 1/2. No way. we can't do this. So that means there is no possible values. Too bad. Now, let's go ahead and talk about how we can come up. This is the second part of the video, and I'll try to add the timelines there so you can see. The second part is I'm just going to talk about coming up with a functional equation. All right? So you start with the solution first. So this is how you can come up with a functional equation on your own. Now, the reason why I want to come up with functional equations is because a lot of times the problems in the books are pretty hard, and some problems, some competition problems like IMO problems, they're really difficult. So I wanted to look for some simple entry-level problems, and it's very hard to find, so that's why I decided to come up with mine. Anyways, I talked too much, so I'm going to stop and get to work. So suppose you want the solution to be f of x equals x. So you start with the solution, and then you have to set up the left-hand side of your equation. Now remember, in a previous video, remember that? I think it was on September 8th, we did this video, f of x over f of y. Now, if I want f of x equals x to be the solution, let's go ahead and evaluate this. What is f of x over f of y? What is f of y, first of all? It is y, so f of x over y. What is f of x over y? By this definition, it is x over y. There you go. Here's your problem. I came up with the problem just like this. That's why I called it homemade, homemade, and homemade. And some people still copy it, but anyways, that's another story. Okay, let me show you another example. Now, if a problem is a competition problem and someone else does it, that's okay. But anyways, don't worry about it. I'm just, so what is the solution? What do you want the solution to be? Okay, I hear you say f of x equals to x plus 1. I'm just making it up. Now, and on the left-hand side, here's what I want. And I think I gave you a problem like this before. I want to have f of x plus f of y. You don't have to have that. You can have f of x minus f of y, f of x times f of y. You can just be creative. So what is f of this? F of x is 2x plus 1, so it's just going to be 2 times that plus 1. But what is f of y? F of y is 2y plus 1. And just do the math, and you're going to get the answer, 2x plus 4y plus 2 plus 1, which is 3. Here you go. Here is your functional equation. See, this is why I kept saying, like, coming up with a problem like this is actually fairly easy. And that's basically how you can do it. Now, when you solve this problem, of course, the solution method, you don't know the answers, so it's definitely harder. And when I solve these problems, people are like, oh, wow, that's crazy. Well, it's not that crazy, actually, from my perspective, because I already know the solution. I start with the solution. That's why it's not too hard. But anyway, so for example, you can start by replacing x with negative f of y on both sides. That's going to give you f of 0. On the right-hand side, you're going to get f of y, so on and so forth. Solution is easy, but that's pretty much the whole idea of how I come up with functional equations. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.